Hello, welcome back. I'm going to do a question here on linear motion, but it's a branch of linear motion, a branch of kinematics, which doesn't look linear, and that is ballistic trajectory. Okay, particularly when you know the departure angle of the projectile is significantly less than 90 degrees, in other words, less than vertical. It looks like a nice big arc, and you think, oh, I must analyze that with, rotational motion. No, we don't do that. Okay, let's look at a question here. Let's just propose something here. It's based on a question you might recognize from a textbook. I don't know. Here we go. Let's put a ledge like that, a building, let's say. Okay, and let's make this 80 meters high. That's getting up there. 80 meters up there. Okay. And let's launch a ball at an angle of 30 degrees with a device. It's not going to be it's 50 meters per second, so I don't think it's going to be thrown by hand. But let's have a ball depart the top of the ledge like that at 30 degrees to the horizontal, and with an initial velocity at 30 degrees of 50 meters per second. Okay, VI 50. That's neither x nor I. That's the velocity at 30 degrees. Okay. Now, it's going to end up obviously going through an arc, but that's because gravity's acting on it. If you threw that ball at that angle in the absence of gravity, it would just go off at 30 degrees off forever into space, and there would be no arc. So the arc is due to gravity, but the gravity only acts in the y direction, which is like obvious, but important to calculate or important to capture. Okay. All right, let's ask a few questions here. There's a few obvious questions, and I'm going to draw a different diagram. I kind of constrain myself too much here, but let's do this. Let's a few obvious questions required to find max range, max distance, maximum distance. Okay. That's interesting. How about final velocity? And by final velocity, I don't mean x nor y. I mean both together. I mean the final velocity. Okay. Magnitude and direction. Okay. Magnitude and direction. And I think another interesting thing would be maximum height. Maximum height. Now, all three of those things can be found with the equations of motion, okay? The equations of motion, rectilinear motion, if you will, that's it, these three. That's all we got, okay? And so you think, well, it's not too bad. And it's true that there's only three equations, and we have some unknowns and some knowns, and you could probably just plug them in there. But it's keeping track of negatives, it's understanding which direction is subject to acceleration, and so forth and so on. All right. So it's a fair bit of logic involved. Let's make a caveat here. Neglect air drag. Neglect air drag. Okay. We don't do any of that in typical dynamics course at this level. It's fine to neglect air drag if this is only 5 meters per second. That would be valid. Here, the effects would be pronounced. 50 meters per second, what is that in kilometers per hour? 111 miles per hour, 180 kilometers per hour. There's a significant air drag component, and it's difficult to incorporate because it's an integral. It varies with the square velocity, and of course, as soon as air drag is acting, velocity decays, and so it's an integral in two directions, x and y. But anyways, we're going to neglect it. Pardon me, I'm sipping coffee. Okay. So step one. Um, let's look at what we have for equations. Okay, here's what we know. Not equations, but data as well. Okay. Now with this question, because there's an acceleration in y, and we call that gravity, and not in x. There's no acceleration in x. There would be if we had air drag. There would be deceleration in x, but we don't have it. So x direction velocity is constant. Let's make a note of that. X direction velocity is constant. It does not diminish. Okay. Y direction velocity is subject to gravity. Well, that means that works both ways, and boy, the negatives really matter. You got to keep track of the negatives. Initially, and one of the first things we're going to have to do is split this up. We're going to have to make this into x and y components, right? Resolve that into components. We have to. Initially, the y direction, the gravity, causes a decel in y until the max height is reached. And then it causes an acceleration in y. So these are the things you have to, keep front and center. You could do a whole bunch of math, and none of it could be right. I'm sorry, but these equations right here, it's not enough just to plug in numbers and hope for the best. We actually have to get the right answer. All right. So I don't mean to make a threat, but that's the reality. X direction velocity is constant. Y direction velocity is subject to gravity. Okay. At max height, Vy equals 0. Okay? That's the definition of max height. That's when the velocity in y goes up and then stops and comes back down again. So that's, okay, that's interesting. Okay? Max height Vy equals 0. I think that's all I'm going to list on here right now. Let's actually list data. Okay? I'm going to split this thing up into x and y right now, right off the bat. Vx equals, well, 50 cos 30. 50 cos 30. Right? 43.3 meters per second to the right. And again, that's not going to diminish. Okay? Vy, and that's Vx initial, Vy initial, 50 sine 30. And of course, that's going to be upwards. So that's going to be initially a positive number, but that's all we know right now. 30 sine times 50, 25 meters per second straight up. 25.0 meters per second straight up. Okay. Here's one. S original, SY. Okay, SY. It's 80 meters. SY naught. 80 meters. It's 80 meters off the ground, your start point. Okay. Acceleration in y equals g equals negative 9.81. Negative. It acts downwards. Now I'm recommending that you stick with the good old coordinate axis system, positive, first quadrant positive, okay? In fact, let's sketch this out here. We have this going on, we have that going on. This is x, y. Just stick with that. For instance, if you said, I'm going to throw the ball straight down from here, and I'm going to call the initial y velocity positive, and I call gravity positive, you get the right answer. But I'm just saying it's a bit of a slippery slope. You start abandoning this, and it's easy to get mixed up. So I'm not going to do that. I'm just going to stick with upwards y velocity, displacement, whatever, positive. Velocity, displacement, and x to the right, positive. Okay. It looks like this. Here's the building again. I'm going to draw it so I can draw the flight path here. Okay. There's the building, 80 meters. Okay. And here's x and y. So we have Vx like that, or sorry, Vy like that, Vy initial, and Vx initial like that. Okay. And the flight path looks like this. You know what it looks like. It looks like this. Okay. And I'm going to assume the ground is level, so let's just go like that. Okay. All right. And we want to know v final. Now v final, I asked for that. What is the final velocity? Well, that's at some trajectory, and we can figure that out. Okay. V final. Right down there. It's at some angle. It's not going to be straight down. There's no way. Not when that's at 30 degrees here. Okay. Here's our max height, which I guess I'll add 80 to it. Let's put it like that. But max height. Whether you include the 80 or not, I don't know. But max height. Okay. At max height. I know the equations are right there in the sheet. It's so tempting to grab one and start working. But let's just get our logic in a row here first. At max height, I've got it up here. Vy equals 0. Vy final equals 0. Now you're saying, well, how can that be Vy final? Isn't there Vy final over here? Well, now you realize, oh crap. To get this, it's a separate problem. Basically, it's got obviously some commonality, the same velocity, the same trajectory, and so on. But the analysis of this first part of the trajectory with regard to y to get the maximum height is basically, once you got that answer, you put it away and you do a second analysis from scratch to find the v final y down here. There's two. There's v final y, vy final here is 0. And Vy final here is something else, and so it's two different problems. Okay, I think that's all I need on there. Let's go ahead and answer one of the questions. It doesn't matter which order you do it in. I'm going to answer well, here's the thing. I'm going to come back to this here. Okay, before I abandon this page. Vx does not diminish. The velocity of x is just going forever and ever, and it would go forever in x, except that the game is over. The time is up when gravity finally draws the ball back to Earth. In other words, the flight is over when the y direction velocity, or when y direction displacement is done. Okay. In other words, flight time is a function of y. All right. So I'm going to say step 2. Realize that flight time is a function of y. Function of y motion, I'll call it. I'll leave it at that. With the x direction, then it becomes just velocity and time, and there's your x displacement. Okay, but let's have a go at this here. Okay, so let's get flight time. Can I get flight time? If it's a function of y, do I have and realize I'm actually starting. I'm not going here yet. I'm going to go here. Total flight time. So I'll make a note of that. Calculate total flight time until ball hits the ground. All right, so I've got an initial velocity in y. It's all about y. It's all about y. Forget x. You got to split your mind in two and say, okay, x direction, yeah, that's a separate phenomenon. It's based on y because the flight time in y is a flight time in x. But y direction, right? So v final y, and now, by golly, don't be telling me v final y here is 0. I don't mean v final y after the ball's landed. That's useless information. I mean v final y at the instant before impact. You ever get hit in the head with a ball? You tell me a 0? No, it ain't 0. So v final y. So I can't use this one because I don't know v final y and I don't know the time. Likewise, I can't use this one. I don't know v final y and I don't know the distance. Sorry, that one I do. I do know the distance. The distance, and you think, that's the distance. It's not the distance in x. I'm doing a y analysis. In fact, I'll write that down. Y analysis. Y analysis from launch to impact. Let's. I kind of already made a little known list here. Let's carry on with that. Okay, known. So I'm really making an effort to keep the logic, intact here. Known. V initial, and this is all y direction. 25 meters per second straight up. Acceleration, negative 9.81 meters per second squared. And displacement, well, displacement is an absolute. It's like, where do you start, where do you finish? Doesn't matter if you go wandering through the neighborhood or through everybody's backyard. That's not what it's about. If you come out of your buddy's house on a Friday night and you had a couple too many pops, and you wander all the way through the neighborhood to try to get to your house, and your house is only 3 doors down, the displacement is only three lot widths. The fact that you wasted a bunch of time wandering around the neighborhood doesn't affect the displacement. Okay, so let's get that clear. The displacement here is negative 80. S equals negative 80 meters. If you call it positive 80, you get the right answer to a different question. Well, that's not quite good enough, sorry. Okay, so do I have what it takes to do this one? Sure, I know V initial, acceleration, and S. Let's use that equation. So that'll give me V, and you think, well, that's not time. Yeah, it's not time. Okay, but if I get V final, then I can use one of the other equations to get the time. So this makes sense. So V final squared. This is a y analysis, remember. V initial squared plus 2as. V final squared, I don't know it. V initial squared, 25 meters per second, all squared. That's positive number, right? XY positive, first quadrant, plus 2 times negative 9.81 meters per second squared times negative 80. Now what might happen is you might get some weird numbers. Like this is going to be a negative number. Let's go ahead and crunch that. All right, 80 negative times 9.81 negative. Well, duh, that's a positive number. Okay, times 2 plus 25 squared. Now is not the time to forget a square root or a square rooted. Okay, 46.84 meters per second. 46. Now, hang on. I'm going to do one more time. 46.85. I'm going to do one more time. 25 squared plus 2 times 9.81 negative times 80 negative. 2194.6 square rooted. 46.85 meters per second. Oh, yay. That's the answer. You know what? Obviously, I think, don't be so quick that's negative. It doesn't, and you say, well, how can it be negative? Well, you just got to know, sorry. Okay, i.e. down. Again, there's just no space to abandon logic here. You can't just execute on hopes and dreams. Okay? All right, so we've got V final. Let's get the flight time now. This is easy. V final. This is an easy one here. You can use either one, hey? You can use the S one, but this is just easier. V final equals V initial plus AT. All right. V final, negative 46.85 equals V initial. Well, that's 25, but it's a positive number. It's going upwards. Plus negative 9.81 meters per second squared times T. T equals. Now, if you didn't have the negatives in the right way, you get a negative time. Now, stop right there, okay? This isn't Back to the Future. So, right, so watch out. Negative 46.85 minus 25 is, watch your negatives, minus 25, get it over there, divided by 9.81 negative. 7.32 seconds. Okay, 7.32 seconds. That is the answer. I did not ask that. It's not one of the questions. Here's a question I asked. Hey, what's the maximum distance? What's the final velocity? Both that, the resultant, and what's the maximum height? So it's not really the full answer, but we did it. We did this. We got calculate total flight time. Okay. Well, you know what we can get right now, and there's other, you can do things out of order if you want, but right now, because we have total flight time and the x direction velocity, the x will just keep on going until the ball hits the ground. Well, now we know the ball will hit the ground in 7.32 seconds. So now we can do the range. Step 3. Calculate range. In other words, how far does it move in x? Okay, calculate range. Okay. All right. Here's a reminder. Right, we're doing this. It's coming off there like that. It's going like this. Okay. And that's SX. That's what we mean by range. SX. There it is, right there. Okay. I'm not going to miss 80 meters. I'm not going to put all the dimensions on here. 80 meters. Okay. Well, I know the time and I know the initial velocity. And you can just, you have to be this one. I want to know range, so I want to know S. This isn't helpful. There is no acceleration in S. This just says final velocity equals initial. Well, we know that. There's no x direction decel going on. So the only choice is this S equals VIT, right? S equals VIT. This is x direction analysis now. VIT plus 1/2 AT squared. SX, if you want to call it that distance right there. V initial, well, that's 43.3. The x component of the initial velocity times 7.32 seconds. Okay, plus, I'll put it in a double liner, 1/2. Hey, wait a minute, A equals 0. Aha, T squared. No decel. S equals. So it actually turns into it's just velocity times time. I could have skipped the second half. This is 0 because there's no acceleration in x. That's only gravity's only in y. Okay, so it's 43.3 times 7.32 seconds, 317 meters. 317 meters. That's a third of a kilometer. Okay. You launch a ball, and this is legit. Look at that. It takes care of the ballistic trajectory. In fact, that's got nothing to do with it. It's just an interesting sort of observation as you watch a ball go through the sky. It's in this arcing motion. But this is the right answer. Sans air drag. Okay. In reality, you'd be lucky to get 200 meters, maybe 240 or something. I don't know, but okay. All right. So that's the first one, maximum distance. Now, let's get the final velocity one because we're kind of on that trajectory. Sorry for the pun, but let's get the final velocity here because I already have v final x, right? That's negative 46, and you know what? I already have v final y, and you're like, wait a minute, did I miss something? No, you didn't miss something. Let's call this step 4. Calculate final velocity, i.e. resultant of x and y. It's not, I don't want to know just x or just y. I want to know the final velocity. Resultant of x and y plus the direction. Okay. So here we go. V final y, well, I have that already. I just did it in the previous page. Negative 46.85 meters per second. V final x is V initial x, which is, what did I say it is? 43.3 meters per second to the right. No decay. There's no air drag. And for sure, gravity doesn't act sideways. So this is it. I've got it. Look it. Here's the final velocity. The final it's you got to resolve the vector. It's 46.85 down. And 43.3, and I'm going to draw them purposely a little bit. You know, the links are somewhat complementary. And here's the resultant, of course. Right? V final. Well, that's just the square root of the sum of the squares. 43.3 squared plus 46.85. That's part of it. You got to get the angle too. V final. Somewhere in between those two, eh? 43.3 squared plus 46.85 squared equals square rooted. 63, oh, I said somewhere between the two. Duh, no. 63.8, one more time. 43.3 squared plus 46.85 squared equals square root. 63.8 meters per second. You think, what about the negative? Well, yeah, it gets squared, okay? Don't get excited. This, yes, but it's squared, so it doesn't matter, okay? And the angle. Because a vector is magnitude and direction. So let's get the angle here, okay? That is, draw a little triangle. Just draw a little triangle, right? I want to know the angle from horizontal. That's normally how you produce, or how you know, especially with trajectories. Theta, okay? Here's a little triangle like that. We don't actually need the hypotenuse. We can do it with the two sides. 43.3, 46.85. It's a function of tan, eh? Theta equals inverse tan. Opposite over adjacent, 46.85 over 43.3. Theta equals, okay, 46.85 divided by 43.3 equals inverse tan, 47.3 degrees. Okay. Make sure you're in degrees, not radians. So it comes in, so this ball over here, it comes in here, this right here, we know this now. That is 63.8 meters per second at an angle to horizontal of 47.3 degrees. Right? That answers the second one. What's the final velocity, magnitude, direction? All right, a separate question. The max height. A separate question. How high up here? It's not completely separate. I mean, the input values are the same, but it's a different analysis, okay? So step 5, maximum height. Let's see if I can fit it in down here. Maximum height. Okay? Let's have a look here. Sip of coffee, sorry. Now it's only a function of y direction. Again, you got to be ruthless. It's only a function of y direction. In fact, you could just say, well, v initial is, what did I say there? V initial is 25 meters per second straight up. And v final is 0. It stops and then it reverses. And the acceleration in that region is negative 9.81 meters per second squared, okay? I want to know S, right through here. I want to know S. Well, holy smokes, look at that. Isn't that nice? That one will work. Right? This one won't work. This one won't work because I don't know the time. But that one will. So v final squared, here we are here, v final squared equals v initial squared plus 2as. Well, that's 0. The final's 0. It stops and reverses. So it's 0 equals 25 squared plus 2 times negative 9.81 times s. S equals, and that is your maximum height. Now it's going to be from the top of the building. If you know, if you want to add 80 meters to it, be my guest. This will be maximum height above the top of the building. Okay, 25 squared. Note the negatives play nice. 25 squared, but you move it over to the other side of the equal sign, so it's a negative divided by 9.81 negative divided by 2, 31.86 meters above the top of the building. Okay, one more time, make sure I didn't get that wrong. 25 squared, move it over to the other side of the equal sign, it's a negative, divided by 2, divided by 9.81 negative, 31.86 meters. Okay, that's it. That's the three things answered. Okay, maximum height 31.86 or 111.86 above the ground. Okay. I hope you learned something from that. It's all about these ballistic motion questions. It's all about splitting up x and y. It is all about that. Treat it as an x direction and a y direction, two separate problems. The only link between the two is the flight time. Okay, got that? The only link. Y direction analysis gives you max height and flight time. X direction analysis, once you know flight time, gives you the range. Both together give you the final velocity and the trajectory. Okay, they're all the same. Watch your negatives and practice a few, and just take a breath when you're doing the questions and make sure you don't make an assumption that's incorrect, especially on direction and so on. Okay, take care. Good luck.